All right, let's get right into it. Today, we're going to demystify a really important concept in algebra, factoring. We're going to break it down into simple, easy-to-handle pieces so you can see exactly how it works and honestly why it's such a cool and powerful tool. But before we even touch the numbers and letters, let's start with a bigger question. Just think about it. How do you solve any giant, complicated problem in your life? I mean, where do you even begin when something feels totally overwhelming? Right. You break it down, you find the smaller, more manageable parts. Well, guess what? That is exactly what factoring is in algebra. It's a way of taking a messy expression and finding the simpler building blocks that multiply together to make it. So, what's our game plan today? First, we're going to build a solid foundation. Then we'll get into something called the highest common factor, or HCF for short. After that, we'll see how that same idea applies to algebra. We'll put it all together, and I'll even show you a really quick way to check your work so you know you got it right. All right, first up, the factoring foundation. And here's the good news. You already understand this, I promise. We're starting on familiar ground with just simple, everyday numbers. So let's be super clear. What is a factor? It's just a number that divides into another number perfectly. That's it. For instance, 2 and 3 are factors of 6 because, 2 times 3 is 6. This one simple idea is the building block for everything else we're about to do. Okay, so that's what a factor is. But what happens when you have a bunch of different numbers? We need to find what they have in common. And that brings us to our next big idea, the HCF, the highest common factor. The name really says it all, doesn't it? If you've got a set of numbers, the HCF is simply the biggest factor that they all share. It's the largest possible number that can divide into every single one of them without leaving anything left over. So, how do we find this thing? It's actually a pretty simple 3-step recipe. First, you break down each number into its prime factors, its most basic ingredients. Second, you look at all of them and circle the prime factors that they all have in common. And last, you just multiply those shared parts together. And bam, that product is your HCF. Let's look at a quick example with 6, 12, and 18. When we break them all down, what do we see? Well, they all have a 2 in them, and they all have a 3. Those are their common ingredients, so we just multiply them, 2 times 3, and that gives us our HCF, which is 6. Okay, you've got this down for numbers. You're a pro. Now, for the fun part, let's apply this to algebra. And I'm going to let you in on a little secret. The logic is exactly the same. The rules don't change one bit. And this slide just shows it perfectly. Look at this. On the left, there are the numbers we just did. And on the right, algebraic terms. But check it out. The process is identical. We break everything down, even the variables. What's common to all 3 of those terms? Well, they all have a 2, and they all have an x. So you multiply them together, and the HCF is 2x. See? It's the same exact thinking. So now that we can find the HCF of pretty much anything, we are ready for the main event. Using that skill to factor an entire algebraic expression. This is where it all comes together. To really understand this, let's look at a simple rectangle. We're just going to find its perimeter, but we're going to do it in 2 different ways, and this is going to prove a really important point about what factoring actually is. So the first way is pretty obvious, right? Just add up all the sides. X plus y plus x plus y. That gives us 2x plus 2y. The second way, we use the classic formula. 2 times the length plus width, which gives us 2 times the quantity x plus y. Now, here's the key. Since both methods describe the same rectangle, these 2 expressions have to be equal to each other. And right there, that's it. That is the essence of factoring. It's like we're just undoing the distribution. We're taking an expression that's written as a sum, like 2x plus 2y, and we're rewriting it as a product, things multiplied together, like 2 times the quantity x plus y. Okay, now that you get the basic concept, let's try it on something a little more complex. How in the world would we factor an expression like this with 3 terms? Well, step 1 is always the same. We look at all the terms, 18x, 24xy, and 12xc, and we find their highest common factor. And using the method we just learned, we'd find that the HCF is 6x. This is the piece we're going to pull out in front. And now for the really crucial next step. We take that HCF, or 6x, and we divide each of the original terms by it. The question is, what's left over after we divide each of those pieces? The final result looks so clean. The HCF, that 6x sits outside a set of parentheses. And inside the parentheses, that's just the results of the divisions we just did. And there you have it. We've successfully factored the expression. But how can you be 100% sure you got the right answer? I mean, really sure. That's where our final section comes in. Let me show you a foolproof way to check your own work. It's incredibly simple. Just multiply it back out. Distribute that term on the outside to everything on the inside of the parentheses. If what you get matches the expression you started with, you know for a fact your answer is perfect. Oh, and here's a quick pro tip for when you're dealing with negative numbers. If you decide to factor out a negative, just remember to flip all the signs inside the parentheses. That's really the only trick to it. And this really just gets to the heart of the whole thing. The whole point, the standard way of doing it, is to find the highest common factor. Pulling out the HCF is what gives you the simplest, most useful factored form of any expression. You know, we started this whole thing by saying factoring is just a way to break down big problems. It's about looking at a complex mess, identifying the core elements that everything shares, and then using that to simplify the whole structure. So the final question I'll leave you with is this. Where else in your life can you apply that exact same powerful way of thinking?